lesson, we'll be doing an example on how to calculate the final amount at the end of the compounding period. So the question says, Lwandi made an initial deposit of 23,000. This is something to highlight. So he made a deposit of 23,000 into a savings account, into an investment account that paid an interest rate of 9.25% compounded quarterly. After 3 years, since the start of his investment, he deposited 13,500. So this means, sorry for that. So this means that he is gonna make this another deposit at the end of 3 years. Okay, so the interest rate is then changed to 8.2% per annum compounded monthly, no longer quarterly but now monthly. So it's gonna be changed when? After 3 years. Okay, so let's see. Exactly after 5 years after his initial deposit, Lwandi withdrew 9,000. Calculate the total value of the investment in Lwandi's account at the end of the 5th year. So they want to know, for 5 marks, how much will Lwandi have after 5 years. So now let's see. The first thing will be to draw a timeline. Like I said, we draw 2 timelines. The first one will show the interest rates and the other one will show the payments which are made. So let's see. So here are my 2 timelines, and we know the duration will be from T0 and T1, T2, T3, T4 and T5. So this represents the number of years. So let's see. The interest rate will change after 3 years. That is here. Right. So for the first 3 years, the interest rate was compounded quarterly and was 9.25%. So we can write this as a 9.25%, or we can take the 9.25% and divide it by 100. Okay, so they mean the same thing, and then it's divided by 4 because it's quarterly. Okay, so this is the interest rate for this compounding period. And then after 3 years, it's going to change to a different amount. So now the interest rate will now be charged monthly, and the value will be 8.2%. So the interest rate here is now 8.2%. So this 8.2% divided by 12 because it's being compounded monthly. Okay, so now this is what we know for now. And then Lwandi made an initial deposit of 23,000 at T0. That is initial. The word initial means at first. Deposited 23,000 into the savings account. The word deposit means you add, and withdraw you subtract. Okay, so because you deposit is plus 23,000, so here will be positive 23,000. That is at T0. And then after 3 years, he deposited 13,500. That is here. It's gonna make another deposit, so we add. This is positive 13,500. It's because the account gains money instead of losing money. Then after 5 years, directly after 5 years, it's gonna withdraw 9,000. So we subtract. So it's minus 9,000 over here. So let's see. Now we have all the information. We can calculate the final amount that she or he will have here at T5. Okay, now let's see. First of all, I'm gonna start with the first payment of 23,000, and it's gonna be compounded 2 times because why? It's gonna experience the 9.25% for a period of 3 years, and then it's gonna experience the 8.2% that is compounded monthly for a duration of 2 years. So to know how long it has been charged, you take here where it ends at T3, subtract T0, and it's 3 years. So the duration of this is 3 years. And this one is T5 minus T3, that is 2, and this is 2 years. So all in total, I've got 3 plus 2 years, which gives us 5 years, and that is exactly what the question wants. Now let's see. Well, I'm gonna start with the first payment of 23,000. The formula says that A is equal to P multiplied by 1 plus I to the power of n. Okay, so now the initial amount is 23,000. So this will be equal to 23,000 multiplied by 1 plus the interest rate. You just plug this as it is, 9.25%, and I divide that by 4 because it's being compounded quarterly, and then I'm gonna multiply 3 years by 4. Okay, remember what I said, when you divide on the interest, you multiply on the value of n. So 3 times 4 will be 12. Now this formula or this equation here will give us the value at T3, but that's not where it stops. Okay, so this amount will now become the value of P for the remaining years. So we'll continue to grow, and then it will end the interest rate that is charged monthly. So this will gain an interest of 1 plus 8.2%, and then I'm gonna divide everything by 12, and I've got 12 multiplied by 2. Remember, here I divided by 12, and I've got 2 years, so I'm gonna multiply 2 by 12 to get 24. And now if we plug that on the calculator, let's see what we get. So this is 23,000. I'm just quickly gonna punch that on the calculator. And that gives me 35,000. So the amount at the end of the 5 years will become 35,633. That is 633,152. So in your exam, they will tell you to round off to 2 decimal places, but for calculation's sake, we are still in the middle of the equation. Do not round off, we will round off at the end. So now let's see. Because I deposit, look, I deposit 23,000, but after 5 years, this is how much I have. You see, it's good to invest. So you must invest your money so that it can grow after a certain period. So now I'm gonna cancel here. Oops, sorry for that. Okay. This doesn't want to go, so I'll try using this one. Okay guys, I'm just gonna switch down the slide. So I'm gonna now do 13,500. I'm gonna compound it. Okay, so let's write it here. So how much will the 13,500 grow by? It's gonna experience only one interest rate because it only starts here. So it's not gonna experience the quarterly interest rate. Okay, so likewise the formula is A, but I won't repeat the formula. So the formula is still the same. And then the amount A will be P multiplied P, okay, which is 13,500, okay? So P is 13,500 multiplied by what? 1 plus the interest rate of 8.2%, and that is charged monthly. So don't forget the percentage or else your answer becomes wrong. And I divide that by 12. Raised to the power of 2 times 12, that is 24. And let's see how much this one will become. So this will be 13,500 multiplied by 1 plus 8.2. And this will become 15,897,024. So now I have this 9,000 that is minus. I'm just going to calculate this as positive and then I subtract it. Now let's see. I invest money here. I take it out at the end of 5 years. It's not going to gain any interest, right? So it's going to remain 9,000 as it is because the compounding period has ended here. So this one is not going to gain any interest. It's going to remain negative 9,000. So now the final money which I will have, which I can call A total, will be equal to this amount over here. I add this one and then I subtract 9,000. So I'm just gonna do that on the calculator and write the final answer so you can add them with me. So the final answer for that will be how much? 42,000. So this is 42,000. So you can write this as rands. So it's 42,530 comma 18, and this is the amount which will be in the account at the end of 5 years. So I hope this question was clear. So now to go to the next question, let's try to erase here. Oops. Okay, I erased the wrong thing. So okay, let's erase this one. Okay, so now the next question says to us, at the end of 8 years after the initial deposit, Lwandi decided to withdraw and use his money and use the money. Okay, so this is the money which he or she had. We said it was, let me write it here. So the money we said that we'll have is 42,530 comma 18. So this is the money that Lwandi will have. Okay, so now this money will not gain any interest because it's now withdrawn, so it's gonna remain this amount. It won't grow to anything, it just remain this amount. So that's after 8 years. You see, after 8 years from the initial. So we've got 5 here, so we're just gonna have 5, then 6, 7, 8, but it doesn't, we're not sure if it ends, it doesn't end the same interest because we are told to calculate the annual interest rate. Okay, so we must calculate the interest rate here. So now at the end of 8 years, they withdraw this money, then calculate the annual interest rate in the final 3 years if the final balance was 64,487.24. Okay, so now how are we gonna do that? Let me try to erase these things. Okay, I'm just gonna do them manually. My rubber is failing me. Okay, so now let's see. So we know that the formula says that A is equal to P multiplied by 1 plus I, everything to the power of n. So now let's see. We know that I must be divided by 12, right? So this is what I'm going to do. I'm going to try to manipulate the formula before I plug in the actual values, because that helps a lot. Okay, so I'm quickly going to erase this ones, this remaining stuff. Okay, nice. So let's go down to the question now. We know that at the end, this is the formula, so we're looking for the interest rate. We're looking for the interest rate, right? So the interest will be charged when, let's see, okay, compounded monthly. Okay, yeah, so it's 3 years will be multiplied by 12. So our n for this question will be 3 years multiplied by 12, which is equal to 36. Okay, so that's the value of n, and the interest rate we do not know what it is, and the final amount A is given that they will have 64,487.24, and the initial amount is the amount which you withdrew. This one, this 42,000. Okay, so it's 42,530.18. So now let's see. So I'm gonna have A over P, if I divide both sides by P, is equal to 1 plus the interest over 12, right, to the power of 36, because that is what we are trying to get rid of. That's the number of years, okay, or the compounding period is 3 years for 12 months, so 3 times 12. Now to get rid of this one, I'm gonna apply the square root of 36 both sides. even this side I'm going to apply the same. Okay, so it's the square root of 36, and this will be the root 36 of a over p is equal to 1 plus I over 12. Remember that this 36 and this 36 will cancel, and the remaining will be what inside. So now I can take the 1 to the other side and it becomes a negative, right? So this will be the square root of 36 a over p minus 1. Just do this to it, and if because this one is now gone, okay, it's equal to I over 12. Okay, then multiply both sides by 12 to get rid of this 12 so that I is left alone. So this will be 12 multiplied by the whole thing, and this one will cancel this one, and the remaining is I. So at the end we see that I is equal to 36, this is a over p, minus 1, take note of the negative is outside the square root, okay, don't include it inside the square root, and then everything is multiplied by 12. So let's plug in the values which we have to get the final answer. So this will be the I is equal to root 36. Okay, let me just decrease this root sign. So it's the 36th root of a 64,000. So 64,487, 24, and divided by the value of p, which is 42,530, 18, and we subtract 1 from it, and then everything is multiplied by 12. So at the end, the interest rate, the annual interest rate, let's calculate it to see how much it will be. So this is the 36th root. I'm just gonna punch this all on the calculator. Okay. So the answer for this is 0.1395. But because we know that interest rate is as a percentage, what you can do immediately after that, you multiply everything by 100, okay, to get this as a percentage. So now let's see if we multiply by 100. The answer for that in 2 decimal places is 13.96. The interest rate will be 13.96%, and this is how we can determine the interest rate. So it's easy to manipulate the formula before you plug in the actual values to avoid the error of rounding off. So it's a perfect answer. That's the one that is displayed as the answer. So I hope this makes sense, and this video was just to show you how to use the timeline. Make sure you are familiar with how to use the timeline, because when you do grade 12 finance, you still need the skill of using a timeline. Thank you for watching.